All right, we're going to take a look at the 9.1 video. If I were you, I would pause the video one sec. I would go on Google Classroom and print these notes. If you can't print them, it might be a little harder to follow along. You might have to copy down some of your own problems, which isn't the best. So print this off. I also posted on there this right here, which is a power in root paper. This will be really helpful. It'll actually make things go quicker than using a calculator, so I'll be using this quite a bit. All right, before we get going, there's a few things we always have to take care of. Jackson, make sure you get your feet off the desk. Malia and Bridget, that's a tardy. I know you think foods is a good excuse for being late, but it's not. And Alex, that's a great question, but we're going to have to save that for later. That's not exactly what we're talking about right now. All right, got it all covered. All right, talking about nth roots. So there's two notations that we're going to use. So if we have a root, we're talking like square root 9. This right here, this sign is what we call a radical sign. Kind of a weird word, but so a radical looks like that. Another way that we're going to write this radical is going to be with a power, like 9 to the power 1/2. These are two things that mean the same thing. So a square root, square, think like a 2, and a 2 on the bottom is the same. So you get 3. If I want radical form, I can write, for example, the 5th root of 32. So what I'm asking you is what number times itself 5 times makes 32. Another way I can write it is this, 32 power 1/5. So 5th root, 1/5 power. Either way, you get 2 for an answer. In general, if you're going to take an nth root of a number, an nth root, you're going to use that as your denominator, equals 1/n. All right, let's just try a couple. If I go here, the 4th root of 81. So what number times itself 4 times? Well, if I wanted to rewrite it, I'd rewrite it as 81 to the 1/4 power. It's a different way to write the same thing. Now I'm going to go on my little paper here, right here, and let's try some powers, and then I'll get to the question. So let's just try 3 to the 6th power. So you're going to go 3 to the 6th power. So we're going left to right. 3 to the 6th is 729. How about 5 to the 9th? We'll go 5 over here to the 9th column, 5 to the 9th, boom, that big number there. So if you want to go in reverse, so if I wanted to take, for example, the 4th root of 81, instead of going left to right, I'm going to go right to left. I'm going to go the 4th root, so I'm going to go in this column, down to 81, and now is going to be 3. So 4th root of 81 is 3, so work right to left. All right, very good. All right, you pause it and try the other two. All right, the 3rd root, I'm going to call it 729 power 1/3. If I go on here, the 3rd root of 729, boom, is going to be 9. And the 5th root, I can call it 7776 power 1/5. The 5th root, if I go on here, the 5th root of 7776, boom, is going to be 6. Kind of slick. All right, last thing we've got to talk about is solving. Solving's a little bit tougher. Solving means you have to find not just one answer, but you have to find all answers. So if there's multiple numbers that could work, you got to find them both. So we have x squared equals 144. First, notice the difference here. Now we have an equal sign. So we're going to solve up here. I just gave you a problem just to quick do a calculation and write it down. Got an equal sign. So how do you get rid of a square? Well, that's with a square root. I really like the idea of using what we call a reciprocal power. Take the power and flip it. So this is 2 over 1, a power 1/2. We'll get rid of it. Well, why? Because when you have powers of powers, that's multiplication. Half of 2 is 1. So you have x to the 1 power, which is just x. Well, you can't just do it to one side. You have to do it to the other side as well. So you have half over here. And this means the square root of 144. So I go on here. Ooh, I gave you one that's off the paper. Hopefully you know your perfect squares. This only goes up to 10. Square root of 144, hopefully we all know, is 12. But we underline this up here. We have to find any answer that can work. Is there another one that can work? Well, your graph is actually helpful. If I look at x squared, the graph of x squared down here is a parabola. So you have a parabola. And what would happen if I just graph the number 144? No x's, no nothing, just 144. Well, if you graph it, you'd have a perfectly flat line through 144. And if you notice, how many intersections do we have between graph 1, the parabola, and the flat line? Well, there's 2. One's over here at positive 12, and 1's over here at negative. So we actually have positive and negative 12. We have two answers. So when you have an even set to a positive number, we're going to get two answers. Well, how about the next one? X to the fourth. Well, I'm going to do a 1/4 power and a 1/4 power. That will get rid of that, so x equals. So I'm going to go with the fourth root of 1296. On here, the fourth root of 1296 is 6. But now I have that question, one answer or two? Positive and negative, or just regular 6? Well, your graph is actually helpful. X to the fourth, if you remember, or you can graph it on your calculator, I'm fine. Fine with that, is also a parabola. All your even powers are parabolas. So is that equal to a positive number? Hey, look at that. You got two solutions. You got positive and negative 6. You got two answers. All right, pause it. See if you can do the rest. Okay, next one. I'm going to square root it. So I go on my paper and I say the square root of 64. Well, you know, negative 64 isn't there, but positive. So isn't your answer just going to be, it seems like negative 8, right? Because you got 1/2 and 1/2. So, well, actually, let's check it out. If you want to know how it's going to be, x squared, we already said, is a parabola. Boom. And negative 64, that's a negative number. If you graphed just that number, it's a flat line. Boom, down here. Do my graphs cross? They don't. So that means we have no real solutions. So if you get a scenario where your graphs never cross, you don't get any answers at all. That negative 8 is not an answer. Graph 1 and graph 2 don't cross. Next one, we have power 1/5 and power 1/5. So go to the paper. So we have the fifth root of 1024 is 4. But now you're thinking, oh, perfect. Must be positive 4 and negative 4. Well, hold on one sec. If we have that, the x to the fifth is a slide graph. All odd power graphs are slide graphs. Looks like that, roughly. 1024 is a positive number. That's up here. How many intersections did I get? Just one. And it's positive. So we have the positive answer, not the negative. If I go to the negative, there's no intersection over here. We just get one answer. The last one, you might think, oh, negative numbers, I know what to do with that. That's no real solutions. Well, hold on. We got power 1/7 and power 1/7. So I'm going to do the 7th root of 2187. 7th root, 2187 is 3. Well, let's figure out positive, negative, no answer. What's the deal here? If I have x to the 7th, that's a slide graph. A negative number is down here. Oh, look at that. I get one answer, and it's negative, so negative 3 is my only answer. So if we're thinking about what can happen, when you have even power set to positive, two solutions. Same thing here. Even power set to negative, no real solutions because the graphs don't cross. Odd power set to positive, get 1, and it's positive. Odd power set to negative, 1, and it's negative. So it can be hard to know how many solutions you're going to get.